quantum physics is no more mysterious than crossing the street. A conversation with Chris Fuchs. According to a quantum interpretation called cubism, there's no need for parallel universes or physics mysticism. Recently, physicist Sean Carroll made my head spin with his explanation of the many worlds interpretation of quantum mechanics. In this view, the world around us is just one version of many, many possible realities. Each time an event occurs with more than one possible outcome, reality splits into different versions. The result is that there are endless other realities containing endless other versions of you. The idea behind the many worlds interpretation originated with physicist Hugo Everett in the 1950s. Although it sparked little serious discussion at the time, many worlds has recently attracted growing support among theoretical physicists as a way to make sense of what happens during measurements of quantum systems. Out of many possible outcomes, we can observe that only one actually happens. In the Everettian view, all of the other possible outcomes happen as well, they just branch off into other realities. Not everyone finds a many worlds interpretation useful or convincing, however. While I was researching this topic, I got in contact with physicist Chris Fuchs at the University of Massachusetts at Boston. He had so many outspoken things to say about quantum mechanics that I decided to share his comments in full. In particular, he offers a starkly different way of looking at quantum mechanics, called quantum Bayesianism or cubism. Fuchs put together a picture book explaining his ideas. It's the source of the images in this article. You can read about them in detail here and here. Or you can simply read on, since Fuchs is unable to guide to his ideas about a worldview in which everyone, not just physicists, continually participates in the creation of a single reality. You've written critically about the many worlds, or Everettian, interpretation of quantum mechanics. What are its main shortcomings? Its main shortcoming is simply this: the interpretation is completely contentless. I am not exaggerating or trying to be rhetorical. It is not that the interpretation is too hard to believe or too unintuitive or too outlandish for physicists to handle the truth. Remember the movie A Few Good Men. It is just that the interpretation actually does not say anything whatsoever about reality. I say this despite all the fluff of the science writing press and a few otherwise reputable physicists, like Sean Carroll, who seem to believe this vision of the world religiously. For me, the most important point is that the interpretation depends upon no particular or actual detail of the mathematics of quantum theory. No detail, that is, except possibly on an erroneous analysis of the meaning of quantum measurement introduced by John von Neumann in the 1930s, which is based on a reading of quantum states as if they are states of reality. Some interpretations of quantum theory, such as the one known as cubism, reject that analysis. So your position is that the many worlds interpretation isn't useful because it doesn't constrain our theories of physics? Allow me to get a bit technical to try to get the point across. Would many worlds work if quantum mechanics were based on real vector spaces instead of on complex ones? I would say yes. Would it also work if quantum mechanics used a different product structure than the tensor product? Yes. Would it work if quantum mechanics were non-unitary, that is, didn't obey the Schrödinger equation? Yes. And so it goes. One could even have a many worlds interpretation of classical physics, as David Wallace, one of the most careful philosophers of the many worlds interpretation, once reluctantly admitted in a conference I attended. The many worlds interpretation just boils down to this: whenever a coin is tossed, or any process occurs, the world splits. But who would know the difference if that were not true? What does this vision have to do with any of the details of physics? What would you call the many worlds interpretation, then? Do you regard it more as a narrative about life than a useful interpretation of how physics works? Yep, pretty much. Heck, George Louis Borges' short story Garden of Forking Paths was written already in 1941, whereas Hugo Everett, inventor of the many worlds interpretation, wasn't on the scene until 1957. Have a look at the story. Or consider this passage from Olaf Stapledon's 1937 novel Star Maker. Whenever a creature was faced with several possible courses of action, it took them all, thereby creating many distinct temporal dimensions and distinct histories of the cosmos. Since in every evolutionary sequence of the cosmos there were many creatures and each was constantly faced with many possible courses, and all the possible courses were innumerable, an infinity of distinct universes exfoliated from every moment of every temporal sequence in this cosmos. Sound familiar? These science fiction fantasies have nothing to do with physics, and that should stand as a lesson for those who think many worlds is a necessary or even helpful interpretation of quantum theory. Coin toss. Does a coin toss create a whole new universe? Physicist Chris Fuchs finds that idea as absurd as asking a penny what it expects from your action. Credit, Chris Fuchs. You also object to the idea of multiple alternate worlds on a philosophical level, correct? Depending in no way on the details of quantum theory, the many worlds interpretation has always seemed to me as more of a comforting religion than anything else. It takes away human responsibility for anything happening in the world in the same way that a completely fatalistic, deterministic universe does, though it purportedly saves the appearance of quantum physics by having indeterministic chance in the branches. Here is the way I expressed what I consider the most important consideration in one of my papers, Interview with a Quantum Bayesian. I'd like to quote it at length, if I may. What is the best interpretive program for making sense of quantum mechanics? This question has it completely backward. It acts as if there is this thing called quantum mechanics, displayed and available for everyone to see as they walk by it, kind of like a lump of something on a sidewalk. The job of interpretation is to find the right spray to cover up any offending smells. The usual game of interpretation is that an interpretation is always something new to the pre-existing, universally recognized quantum theory. What has been lost sight of is that physics as a subject of thought is a dynamic interplay between storytelling and equation writing. Neither one stands alone, not even at the end of the day. But which has a more fatherly role? If you ask me, it's the storytelling. An interpretation is powerful if it gives guidance, and I would say the very best interpretation is the one whose story is so powerful it gives rise to the mathematical formalism itself, the part where non-thinking can take over. The interpretation should come first, the mathematics, that is, the pre-existing, universally recognized thing everyone thought they were talking about before an interpretation, should be secondary. Take the nearly empty imagery of the many worlds interpretation. Who could derive the specific structure of complex Hilbert space out of it if one didn't already know the formalism? Most present-day philosophers of science just don't seem to get this. If an interpretation is going to be part of physics, instead of a self-indulgent ritual, it had better have some cash value for physical practice itself. That's a lot to take in. Here's the way I put it a little more colorfully in another paper. Cubism, the perimeter of quantum Bayesianism. Who could take the many worlds idea and derive any of the structure of quantum theory out of it? This would be a bit like trying to regrow a lizard from the tip of its chopped-off tail. The Everettian conception never purported to be more than a reaction to the formalism in the first place. Those papers build on your alternative view, what you call quantum Bayesianism, or Cubism. How does it interpret what happens in the world at the quantum level? A good metaphor for quantum theory from the point of view of Cubism is the Boy Scout manual, in contrast to a Rand McNally World Atlas. The maps in the atlas are an attempt to represent all the places and terrains in the world. Of course, atlases have to be updated from time to time, but the gist of what they are meant to capture in any given edition is a kind of static, timeless entity, that in effect is what the Everettian universal Wava function claims to be, a catalogue of what is in the world. The Boy Scout manual is quite different. It is also reflective of some features of the world, or else it would have no validity, but only some features. Mostly it is meant to be a pliable guide to better living and better productivity for we who swim in the world, no matter what particular currents we encounter. Likewise, In Cubism, quantum states are mathematical entities that we agents who swim in the world may use for better navigation through its currents and eddies. From this point of view, a quantum state is nothing more than a compendium of probability assignments for which consequences an agent might experience if she were to take this or that action upon her external world. Or in a less preferred language, probabilities for the outcomes of measurements. Indeed, for Cubism, a quantum state is not something out in the world, as it is in the many worlds interpretation. Instead, it is a thought in the head of the agent using it. Different agents may even have different quantum states for the same quantum system. One of the central mysteries of quantum mechanics is commonly described this way: objects exist as a blurry Schrödinger wave until observed, at which point they collapse to a specific state. How do you account for that collapse? That's an example of language that Cubism would never use. Objects exist as blurry wave and collapse to a specific state instead. In Cubism, an agent, an observer, has some beliefs about the consequences of her actions on a physical system, or, again in less preferred language, a measurement outcome. She takes some action on the system and notes the consequence. That might well cause her to re-evaluate her beliefs about the consequences of any future action she might take on it. Those re-evaluated beliefs just are the new quantum state assignment. That's all that collapse is. It is a change of one's expectations based upon one's lived experience. And if that's all there is to it, collapse is no big deal. It still seems weird that the observer is an integral part of a measurement. One of the conceptual innovations of Cubism is the recognition that the word measurement was always a misnomer for what is being discussed. Before quantum mechanics, the word measurement was subliminally understood as being about looking and finding, both of them passive processes. In the 1930s, when the various no-hidden variables theorems in quantum mechanics came up, holding that there is no hidden, deterministic process at work in quantum measurements, a number of people started thinking that looking and finding couldn't work. Such thinking led them to the idea that measurement is all about looking and creating. Measurement is both passive and active. Things aren't there before the looking, but looking somehow brings things into existence. So weird. Indeed, mystical. In contrast, Cubism understands measurement as an action an agent takes on her external world, with the concern being what are the consequences of the action for the agent. What does that distinction mean, in practical terms, for understanding the way we interact with the world around us? Viewed this way, of course measurements have a creative component in an indeterministic universe. Measurement is therefore demoted from being something mystical to being about things as mundane as walking across a busy street. It is an action I can take that has consequences for me. The only difference between such everyday events and the happenings in a quantum optics lab is whether it's fruitful to apply the calculus of quantum theory for making better decisions. Quantum mechanics action and experience go hand in hand. To Fuchs, that connection is essential to understanding our relationship to quantum reality. Credit, Mark Staff Branzel. That's the least spooky description of quantum reality I've ever seen. But how can you imagine applying quantum mechanics to the universe as a whole, as quantum cosmologists attempt to do? You're asking, can a cubist do quantum cosmology? You ask, I assume, because I claim that Cubism says that quantum mechanics is like the Boy Scout manual. It's about making better predictions of the experiences important to me. Anyone who uses it, which, by definition, involve me, the same person who uses it. Therefore, for quantum cosmology to exist at all, must it be that I am like a god who can take an action on the universe from outside it? Right? No, of course not. Just as an 11-year-old who opens a Boy Scout manual is not a god, either. He's just a kid doing the best he can in light of the character of reality. For Cubism, measurement is simply about acting from inside the world. The measurement can be about anything from a small thing in front of me to something big, like a room-sized quantum computer, to everything that completely surrounds me. The last of these is quantum cosmology. But there is nothing special about that case. These kinds of discussions always leave me wondering, but is it true? What kinds of tests might allow you to distinguish between the many worlds interpretation and cubism, or to falsify one of them? To the extent that both interpretations are consistent understandings of quantum theory, there can be no experimental test to discriminate between the two. With hindsight, either view can always explain any experiment that can be posed in the language of quantum mechanics. But that's with hindsight. What about with foresight? Here's where a test between interpretations can come about, but it is purely a pragmatic test. Which interpretation promotes or suggests the most new questions, conceptual and mathematical, in physics? Which interpretation gives more guidance for solving various extant physical problems posed independently of any interpretational concern? These are the distinguishing marks that make a difference in the real world, not in the church pews. I am proud to say that the road to cubism has led to quite a number of results in quantum information theory in just this way, whereas I really do not believe this is true for the many worlds interpretation. I once asked Daniel Simon, one of the founders of quantum computation, whether Everett's interpretation of quantum mechanics aided him in finding his now famous quantum algorithm. His response makes me laugh to this day. Everett? Who's Everett? And what is his interpretation? For more science news and ideas, follow me on Twitter, @ChorusPowell. Please save trees and nature. Please subscribe my channel. Thank you. Quantum physics is no more mysterious than crossing the street. A conversation with